Welcome back to Intellipaat's YouTube channel. In today's video, we will be learning about Python generators.
The agenda for today's tutorial is the following topics. First, we'll be taking a look at the prerequisites required to learn about generators. Next, we'll move on to the formal definition of a generator. Later, we'll be taking a look at an example in order to better understand the definition of a generator. Finally, we'll be taking a look at use cases and scenarios in which generators are used. Prerequisites. The first prerequisite we need in order to learn about generators is the yield keyword. The yield keyword in Python is used to return some value from a function without finishing the states of a local variable. Now let's look at an example to understand about yield keyword. Here I have defined a generator function called gen function. The first statement yields x, the character x, and on the next statement I'm printing some other features, and on the third statement I'll be yielding y, and here I'm just adding two numbers and returning the result. And note, I'm not using the return keyword, instead I'm using the yield keyword. I'm yielding the result along with the character z. Now let's call this function and let's see how this works. Now the generator function will have the generator object, which I'm storing in a generator in a variable called generator object. Now if I use the next function on the generator object and print it, let's see what happens. Let me just save it and run it. Now it is returning x, that is, it is yielding the x character. Now when we use the yield keyword, it pauses the function until this statement is executed and the function is paused up to this. Now if I use the next function again, if I just save it and run it, it will print the statement, and then the control goes to the next statement and it yields the character y. Now after this, the generator function is paused up to this point, and then it executes this set of statement and yields the result along with the character z if I call the next function on the generator object again. So let me just do that. If I save it and run it, it is printing it is printing 30 and the character z. Now if I use the next function again, the stop iteration exception is thrown because there is nothing to return from the generator function. So the generator function holds the state of its local variables. Now this block of code can be replaced by a for loop just like this. Now this block of code can be replaced by a for loop just like this. Now if I just save it and run it, it has the same result. So you can use a for loop instead of the next function, which is typically used in the iterator. Now we will take a look at the difference between return and yield. Here I have defined a normal function and I have allowed 10 to be stored in A and the value 20 to be stored in the variable B, and the result A plus B is stored in the variable called result, and I'm returning the result. This is a simple function to add two variables. And if I call the normal function and then print the output returned by the normal function, it is 30. It is adding 10 and 20 and it will return the result 30. Note that if I hover over this statement, it is showing the code is unreachable. That means if you use return statement once in your function, the function is terminated and all the data stored in your variables is destroyed. This will not happen in case of yield. This is the main difference between yield and return keywords. The next prerequisite you should be knowing is the iterators. Iterator in Python is simply an object that can be iterated upon, an object which will return data one element at a time. To know more about iterators, click the link in the top right corner. Next, moving on to definition. A generator is a function that returns an object, an iterator object to be specific, which we can iterate over, and it gives out one value or one element at a time.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective. as it is taught by IIT professors and industry experts.
Another way to identify a generator in a huge source code is to check if there is at least one or more yield statement in the function. It simply means if you see a yield statement inside a function, then you can just assume that it's a generator function. Example. For the example, we'll be writing a generator function which gives out the Fibonacci series. Here I have defined a function called as Fibonacci sequence, and I've initialized the first two digits, that is 0 and 1 of a Fibonacci series. Obviously I have assigned 0 to A and 1 to B, and I have in this statement I have initialized an infinite while loop. In the next statement I'm yielding A, that is returning the value of A, and I'm updating A and B. A is given the value B, and B is given the value A plus B. That is the sum of the current element and the previous element, which is the rule for the Fibonacci series. Now, if I call the Fibonacci sequence, that is the generator function, if I call the generator function, it will return an object, generator object, which I'm storing it in the variable generator. And I'm printing out the first 10 elements in the infinite series, that is the Fibonacci sequence. I'm doing this using the for loop and the range of function. Now, if I just save it and run the code, now, as you can note, Fibonacci series is an infinite set. So obviously you can't hold all the elements inside the function, which will take up a lot of memory. And it is impossible to store an infinite set in the first place. Now, moving on to use cases, it is easy to implement. Generators can be implemented in a clear and concise way as compared to their iterator class counterpart. Because of this, they are used in place of iterators, since generators do not use the iter and next functions. So the first use case is it is used in place of iterators. Memory efficient. When we use a normal function to return a sequence, it will create the entire sequence in the memory before returning the result, and this will cause unnecessary use of memory. Generator implementation is preferred here since it produces one item at a time. So the second use case is memory efficiency. If you want to save memory in your code, then you should go for generators. Represent infinite stream. Generators are the best choice when it comes to representing an infinite stream of data. As we have seen in the example, Fibonacci series is an infinite stream of data. It is an infinite set. Infinite stream cannot be stored in memory, and since generators produce only one item at a time, they can represent an infinite stream of data. Pipelining generators. Multiple generators can be used to pipeline a series of operations. Let's suppose there are two generators, one giving out Fibonacci series and then the other giving out the sum of natural numbers. You can pipeline these generators and add some functionality to it. Thank you for watching till the end, guys. For more tutorials like this, you can visit our YouTube channel. And for blogs on technologies like DevOps, cloud computing, and data science, you can visit the following URL: www.intellipaat.com/blog.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.